All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. What we're going to be talking about over the next couple of minutes will be properties of parallelograms. And so what you might want to do either on the notes that I've given you or maybe on a blank sheet of paper that you're going to use for homework tonight, we've actually got two theorems that we need to discuss or prove before we can actually go about and apply them within the context of your notes here today. And so the first theorem, if you look there on your notes, says theorem 6.1, opposite sides of a parallelogram are. Well, in order to understand what they are going to be, well, the first thought that I hope comes to your mind is that they're going to be parallel, which is very true. You know, we talked about that yesterday when we were classifying these parallelograms. That was our basic definition there. But what I want to do today, okay, and I know that doesn't look like a great parallelogram. I probably should have drawn that out beforehand, but let's go ahead and sketch out a parallelogram on our page here. All right, and we can actually go ahead and show that these opposite sides are going to be parallel to each other, okay, because that's our basic definition. And then I'd like you to go ahead and just go ahead and draw on a diagonal there. Okay, like I've told you before, a lot of things in geometry come back to the very basic structure, which is going to be a triangle. Okay, and the question I'd like you to ask yourself is this: is triangle ABC congruent to triangle CDA? Now, I know a lot of you are as you ponder that, you probably have already marked down the reflexive property, which is good. Okay, of AC being congruent to AC. But outside of that, is there anything else that I can mark congruent within that structure that isn't already marked congruent? Okay, and here's what I would challenge you to think about. With the lines being parallel, what else would have to be true? Well, we've been talking a lot recently about the alternate interior angles being congruent. So I'm going to go ahead and mark this angle congruent to that angle. And I'm going to mark this angle here congruent to this angle here. All right. So as a result of the triangles congruent, yeah, they're congruent by angle, side angle. Okay. Now, if those triangles are congruent, what do we know about their corresponding sides? Well, they are too going to be congruent. So I know that this side AD would be congruent to this side BC, and I know that this side AB would be congruent to this side CD. So if I go back to that theorem there, opposite sides of a parallelogram are, what I want you to jot down, they are congruent. Okay? Opposite sides of a parallelogram are congruent. If we look at theorem 6.2, I can continue with this same proof right here and prove theorem 6.2, opposite angles of a parallelogram are. And here's what I would show you. I know that if those triangles are congruent, I would then know that angle B over here is going to be congruent to angle D over here. Again, all this is by CP, CTC, right? Okay. And so if I look at this, what are the opposite angles? Well, I know that this angle here at D is congruent to this angle here at B. Okay. And I also know that this angle here at A, the whole angle, is congruent to this angle here at C. Okay. And so as a result, we know that the opposite angles are going to be congruent as well. Okay. Now, one thing that you can think about, I think it might be easier for some of you to actually put numbers in here. And this is what we're going to be doing in a little bit here. If I go ahead and label this again, my quadrilateral, my parallelogram ABCD. Okay, and again, I want to make sure that we understand that this is a parallelogram, so I'm going to do this. Okay. And I just pick a random angle measurement out for one of those angles there. So if I look at B, I know that the measure of angle B, well, it's an obtuse angle, so let's make it 110 degrees. Okay, just picking a random degree out there. Now, what do we know about this angle here and this angle right here? Well, I hope your thoughts are going to the fact that those two have to be supplementary. Those two angles are same side interior angles. With the lines of BC and AD being parallel, that makes them same side interior and they have to be supplementary. So I'm going to go ahead and make that 70 degrees. Now if I continue working my way around the figure here, if this angle right here is 70, what does this angle have to be? Well, since AB is parallel to CD, these two angles are going to be supplementary as well, so I have 110 degrees. Okay? Sorry for the sloppiness there. 110 degrees. Well, right now you can see that we've already proven that the opposite angles there are congruent to each other. If I work my way around the figure again, with BC being parallel to AD, I know again that these two angles have to be supplementary to each other, so 180 minus this one has to be this one right here. Again, thus proving that the opposite angles are congruent. Okay? Again, that comes back to that they're all same side interior angles as we relate around the figure. So, the next thing I'd like to do, if we go back to the notes, the worksheet there, let me pull that up real quick. Let's see here. Is that going to work? No? Okay. The next thing I'd like to look at is going to be that last statement right there, which is this: consecutive angles are angles that. Now, when I say this, consecutive angles would be like angle R and angle Q. Okay, they're next to, they share a line right there. Okay, R and S share a line right here. Okay, so you can jot that down right there. The reason I put that there is because in years past, I've had some classes that have struggled with the understanding of what same side interior angles are, and so I come back to the understanding that these are consecutively in a row. If the lines are parallel, these have to be supplementary. Okay, so again, if you see that term consecutive angles anywhere, they share a line. Okay. All right. Now, if we work our way down the paper here, let's look at these first two examples, and then what I'm going to encourage you to do after that is actually go ahead and try the rest of the paper on your own. I'm going to tell you that you can probably do the rest of the paper faster than I could probably do it explaining it. And then I would probably come back and just double check like you guys do, put on 3 or 4 times as fast. Make me sound like a chipmunk probably as you as I speed through the lesson there. But just just double check it. Make sure all your answers are the same. If they're not the same, then maybe slow it down and make sure you understand why they are what they are. So let's talk about this first one. Find the value of x in the parallelogram PQRS, then find the length of QR. Well, what we just got done talking about is that these opposite sides of the parallelogram have to be congruent. Okay? And so as a result, I know what the equation is going to be to solve for x. All right? And so from there, once I've got that equation, I can go ahead and subtract 2x from both sides and add 15. And I know that x is going to be a length of 18, whatever units it is. Now it does say find the length of QR, and I think you guys are doing a real good job with this, substituting this back in. And if I do that, 3 times 18 minus 15, let's see, 3 times 18, 54 minus 15, let's see here, 39. So the length of QR right here would be 39 units, whatever that unit would be. Okay? All right, so yeah, that's how you would set that one up right there. For the next problem, find the value of y in the parallelogram. EF, GH, then find the measures of the angles. I'm going to tell you right now, you're going to notice something interesting at the very end of this this problem, and I'll explain that in just a second. Let's see if I can. There you go. Okay, so the first thing I'm going to do here is go back to what we talked about at the very beginning of the period. Well, these opposite angles have to be congruent, right? Okay, so I'm going to go ahead and set 3y plus 37 equal to 6y plus 4. Okay. Now, if I go ahead and solve for y, lots of different ways you can do it. I'd probably subtract 3y from both sides, and then subtract 4 from both sides. Now I can just divide by 3. Okay. We know y equals 11. Now, the interesting thing that I was mentioning just a moment ago is this. If I go ahead and figure out what the measures of each of these angles will be, 3 times 11 is 33, plus 37, that's 70. Yeah, 70. So this will be 70 degrees. Now, some of you are probably thinking, why is that so weird? Some of you are like, yeah, that's really weird. Why is that so weird? Just look at angle G. What is it? It's an obtuse angle, isn't it? Okay. And so, there are times in your textbook where they don't draw the pictures to proportion. Like I've told you before, though, most times it will be. So just keep that in mind. If we look at the next angle, it should be 70 as well. 6 times 11 is 66, plus 4, that is 70 also. So we're good there. How would we find angles H and F? Well, again, remember, if this line is parallel to this one, which it is because it's a parallelogram, this angle here and this angle here have to be supplementary. So 180 minus 70 is 110. And then likewise, if you want to do it with these two lines, or you can do it with these two lines being parallel, that would make these two supplementary. So again, proving that the opposite angles are congruent. Okay. So again, I think you can go about doing the rest of the worksheet on your own fairly quickly. I'll begin in a couple of seconds here to try and explain it to you, but if I were you, I'd pause me and just zip right through the rest of those problems there, and then we can talk about if you have any struggles on the rest of those problems. So take a moment and go ahead and do that for me. Okay, again, I hope that you're able to pause your computer and try to figure those out on your own. But if I go ahead and work through this, again, remember these angles here are same side interior, so I want to go ahead and they're going to say supplementary. So this angle is going to be 100 degrees. Okay, since they're supplementary. The next one, I know that the opposite angles are congruent, so this angle here is congruent to this one. And this one's congruent to that one, so I already know angle 2 is 140. And then I know that these are same side interior, so angle 1 is 40, as is angle 3, because the same side interior have to be supplementary if those lines are parallel, which they are. Okay. Same thing with the next one. These angles are congruent, so angle 2 is 110. And then from there, these angles are also congruent, but these are supplementary, or these are supplementary. So again, this is 70, and that's 70. Hey, those are popular numbers today. Okay. For this next one, the fourth one, again, I know that the opposite angles are congruent, so I know angle 1 is 113. And then they're starting to get into some alternate interior angles. Remember, these lines are parallel, so I would make this angle congruent to that angle. And these lines are also parallel. So that would make this angle here congruent to that angle there. So angle 2 is again 45, and angle 3 is 22. Okay. Likewise, we see the same type of problem here. So angle 1 is 115. I know that angle 3 is going to be 50 degrees because of the alternate interior angles being congruent. And then how would we find angle 2? Well, angle 2 can be found by taking the triangle that we have here. We know the sum of the interior angles is 180 degrees. And I would subtract 115 and 50 from that. So let's see here, that'd be 165 from 180, so we end up with 15 degrees. Oh, not 11, 15 degrees there for angle 2. Okay. In the next one, I think where I would probably start is I would probably find angle 2 first by taking 180 from 75 because we have a straight line right here. Okay, so 180 minus 75 is 105 degrees. That's pretty simple there, that's angle 2. The next thing I would probably do is I would probably go ahead and show that the vertical angles are congruent. So that angle here is going to be 75 degrees. And if I add those two together and subtract them from 180, it'll give me angle 3. So angle 3 is 180 minus 75 minus 50. So these two together would make 125 from 180 will give you 55 degrees. Okay. And so from there, I know angle 3 and angle 1 are congruent to each other. And so angle 1 is also 55 degrees. Okay. If we go ahead and, can I move this? Maybe I can just scroll on. There you go. Okay. The last 4 problems here. Again, we're still remaining with the angles here. As I look at this next picture, I think that the easiest thing to do would go ahead and say, I know angle 2 is 72 degrees because they're vertical. They have to be congruent. Then I think probably the next easiest is to go ahead and start with angle 3. And I know that angle 3 is going to be 180 minus 72 because it's a straight line right there. So we have 108 degrees for angle 3. You can go one of 2 different ways here. I know that the alternate 2 angles here are congruent, and I know that the alternate 2 angles here are congruent. Okay? And so if this is 108 here, and this is 40 there, that gives me 148 degrees, and I can find angle 4 by taking that from 180. So 180 minus 108 minus 40, which will give you, let's see, 48, so 32. 32 degrees would be angle 4. Okay. And then for the last one, you probably know where I'm going with this one because it's a triangle. I have 72 degrees here. I have 47 degrees here. Need to find angle 1. So I'll go ahead and do 180 minus the 72 and minus the 47. Okay, now these 2 together, 119 degrees. So we end up having 61 degrees as my angle right there at angle 1. Okay, 61 degrees. For the last one, as far as the angles are concerned, I know that this angle here is congruent to that angle there, so 3 is 50 degrees. I also know that this angle right here at 2 can be found by taking 180 minus 82. So if I do that, 180 minus 82 gives you, let's see here, 98 degrees. Okay. And then to find angle 1, if we know that angle 2 is 98 and angle 3 is 50, angle 1 is going to be 180 minus 98 minus 50. Okay, now these 2 together will make 148, so that gives you 32 degrees for angle 1. Okay. Now again, I hope that as we went through those, I know that was really fast, but I hope that you kind of looked at the picture and, for example, in the previous problem, angle 3 is obtuse, and we get an obtuse measurement. We've talked about that a lot this year, not just putting down random numbers that we think make sense. Make sure it makes sense within the picture as well. Okay. All right, for the last 2, we're talking about the side lengths of the parallelogram. Remember that the opposite sides are congruent, so I might as well just go ahead and mark that there and there. Okay, so what's the length of TI? Well, TI has to be a length of 16. Okay. And then for the last one, this one's a little confusing sometimes. This is not 10. This is segment IO. Okay, and so we know that segment IO is 40 units, whatever it is. So to find the length of OR, if you want to find this length right here, we're going to take 7/8 of 40. So I'll just write that out. OR equals 7/8 of 40. Okay. Now I know a lot of you are reaching for your calculators right now, but let's ask ourselves this. How many times does 8 go into 40? Well, that's 5 times, right? And 5 times 7 is 35. So the length of OR is 35 units, whatever it is, as is TI. Okay, and so that's actually what we're looking for. TI is 35 also. So I hope that was understandable there, folks. You can go ahead and start some practice problems. Again, make sure if you're taking these notes here that you show them to me so I can give you credit for that. So have a great day, and I will see you later.